16 minutes. See, that's all it took. 16 minutes in the air, and China just ended a race the rest of the world didn't even know it was losing. On April 4th, 2026, at a small airport in Zhuzhou, Hunan province, a 7.5-ton unmanned cargo aircraft lifted off the runway. It climbed to 300 meters. It held a cruise speed of 220 kilometers per hour. It flew 36 kilometers, and then it landed safely, having completed every single one of its scheduled flight maneuvers without a problem. Routine, right? Cargo drone makes a flight. Who cares? Here's what made every aerospace engineer on Earth stop dead. The engine in that aircraft burned no jet fuel, no kerosene, no sustainable aviation fuel blended with kerosene. What they actually engineered it to burn, what they fed directly into a turbine spinning at flight power, was liquid hydrogen. Stored at minus 253 degrees Celsius, fed directly into a combustion chamber, producing thrust, producing nothing out the back but water vapor. The engine is called the AEP-100. They built it entirely in China at the Aero Engine Corporation of China's Hunan Aviation Power Plant Research Institute in Zhuzhou. And what they managed to do on April 4th, 2026 was something no country, no company, no research lab on Earth had done before. They flew the world's first megawatt-class hydrogen-fueled turboprop engine, not tested it on the ground, not showed it at an air show. Flew it in the air, on a real aircraft, at power levels that matter for real aviation. And Airbus, the company that has spent years and hundreds of millions of euros on hydrogen aviation, is still in a building in Bavaria running a test stand. By the end of this video, you're going to understand exactly what China built, why the power level is the number that changes everything, and why what happened in Zhuzhou might be the most consequential 16 minutes in aviation since Chuck Yeager broke the sound barrier. Stay with me. Let me talk to you straight, because you've been burned by aviation hype before. You've watched hydrogen aviation make promises for 20 years. You've seen the concept renderings. You've sat through the press conferences. You watched Airbus launch the ZEROe program in 2020 with bold timelines for a commercial hydrogen aircraft by 2035, and then watched that date quietly slide to 2040, then 2045. You watched Airbus cut the ZEROe budget by 25%. You watched them cancel the plan to test hydrogen on their A380 demonstrator outright. You've watched hydrogen startups across the US and Europe raise money, miss milestones, and disappear. You've heard hydrogen aviation is coming so many times it stopped meaning anything. So when I say China flew a hydrogen engine, your gut says, how big? How real? How long until it becomes something that matters? Good questions. Let's answer every one of them. First, what is a megawatt, and why does that number matter more than anything else in this story? Power in aviation is everything. The engines on a regional turboprop, the kind that flies 50 to 70 passengers between smaller cities, the kind that services island routes and cargo corridors, operate in the 1 to 2 megawatt range. That is the segment of aviation where hydrogen advocates have always said clean propulsion is closest to practical. Not intercontinental wide bodies, not 400-seat jets, regional aircraft, short-haul cargo, the first wave. What they engineered with the AEP-100 is an engine that sits right in that range, over 1 megawatt of shaft power, a direct combustion turboprop, meaning it burns hydrogen the same way a conventional engine burns kerosene, not converting it to electricity first. And here's the number that separates this from everything else being developed in the West. The biggest hydrogen electric systems that American and European companies are currently flight testing run at sub 100 kilowatts. Some are at 600 kilowatts. ZEROe, the most funded Western hydrogen aviation startup, is targeting systems for 9 to 19-seat aircraft. The AEP-100 is over 1 megawatt in the air, already flown. That's not a small gap. That is a different class of engine entirely. Now here's the comparison that should stop every aerospace executive cold. Airbus, the greatest aircraft manufacturer in the world by deliveries, 6 years into the ZEROe hydrogen program, hundreds of millions of euros spent. What they managed to build and publicly demonstrate is a 1.2 megawatt hydrogen fuel cell powertrain, not combustion, fuel cell, that ran on a ground test stand in Ottobrunn, Germany in late 2023. That's what they call the Iron Pod. It's impressive engineering. It is never left the ground. Then in 2025, Airbus announced it was abandoning hydrogen combustion entirely and betting ZEROe solely on fuel cells. Entry into service? Now targeting the late 2030s at best. 4 months after that announcement, China flew a hydrogen combustion engine at over 1 megawatt in the air, not a test stand, not a pod in a building in Bavaria, a flight at an airport in Hunan province. And Boeing? America's answer to this? Boeing has published research, has contributed engineering to NASA, invested in ZEROavia through its venture arm. ZEROavia has slipped past its own 2026 target with no flight at this power class. Boeing has no clean sheet hydrogen aircraft in development. They designed a bet. China managed to fly the answer. Now the honest part, because this channel doesn't do hype without honesty. What they flew on April 4th is real, and it is early. ECC's own experts called liquid hydrogen engines currently still in the exploratory stage. That is not spin. That is an accurate description of where the technology sits globally, including China. 16 minutes is not a transatlantic flight. 36 kilometers is not a commercial route. 300 meters is traffic pattern altitude, not cruise altitude. The flight demonstrated that the engine works, that it starts, that it performs stably through takeoff to landing. Did not demonstrate commercial readiness, long-range endurance, or the kind of cycle life airlines need before they sign purchase agreements. The cryogenic storage problem is real. Liquid hydrogen must be kept at minus 253 degrees Celsius. That requires vacuum-insulated tanks, cryogenic pipelines, and specialized ground handling infrastructure that does not exist at any commercial airport on Earth. AECC's own roadmap is explicit. The near-term target for hydrogen aviation is not Heathrow or Frankfurt. Its island logistics, unmanned cargo corridors, remote freight routes, places where ground infrastructure can be built from scratch rather than retrofitted onto a legacy airport. China's own published roadmap puts regional hydrogen aircraft application at 2035, mainline commercial by 2050. Those timelines are honest, and they're almost identical to what Airbus says, except Airbus is starting from a ground test stand, and AECC is starting from a completed flight. That gap is everything. So where does the rest of the world actually stand? America's position in hydrogen aviation, by the most generous reading, is observational. Boeing is watching. ZEROavia is developing. The FAA and EASA are still drafting the airworthiness rules that will govern liquid hydrogen aircraft, and those rules don't exist yet. The U.S. government rescinded over $7 billion in clean energy infrastructure grants in late 2025, including hydrogen hub funding. The policy floor just fell out from under the infrastructure side of the equation. Europe launched ZEROe with ambition and retreated with a budget cut. Airbus is now building toward a fuel cell aircraft. A different bet, a different architecture, targeting entry into service somewhere in a decade-and-a-half window that may or may not hold. And China. A ECC published a 3-phase roadmap. Key technology validation by 2028, regional aircraft application by 2035, mainline commercial by 2050. The thing that makes that roadmap different from every Western roadmap is one sentence. They already completed phase 1, in the air, on April 4th, 2026. So what does this actually mean? Both sides called straight. Here's what it does not mean. It does not mean you'll board a hydrogen flight by 2030. It does not mean Airbus and Boeing are irrelevant. The infrastructure, the certification, the supply chain, none of it exists yet at commercial scale anywhere. A 16-minute test flight is a proof of concept, not a product. But here's what it does mean. And it's the same story we've watched play out with batteries, with solar panels, with drones, with electric vehicles. The open question in hydrogen aviation was, can anyone fly a megawatt-class hydrogen propulsion system in this decade? That question now has an answer. China answered it. They managed to close the loop between ground test and flight, while Airbus was cutting budgets and Boeing was filing research papers. They engineered the complete technological chain from core components through full engine integration, and they proved it works in the air. That is the moment everything starts, because the company that flies first builds the manufacturing base. The manufacturing base drives the cost down. The cost dropping drives the infrastructure investment. And somewhere at the end of that chain, the hydrogen aviation industry that everybody has been projecting as a 2040 story becomes a 2035 story, and it happens in China first. We watched this exact sequence with drones. DJI now owns that industry, while America and Europe were still filing patents and funding startups. China didn't invent the drone. They industrialized it first, And that was that. The AEP-100 is the DJI phantom moment for hydrogen aviation. Here's what I want from you. One honest line in the comments. Airbus spent 6 years and hundreds of millions of euros on hydrogen aviation and is still on the ground. China's state lab flew a megawatt hydrogen engine in 16 minutes, and the West barely covered it. Was this the moment we handed aviation's next century away, quietly, while we were busy arguing about timelines and writing checks to startups that missed their targets? Yes or no? Then tell me why, especially if you work in aerospace. Especially if you've been in a meeting where someone said Chinese aviation technology wasn't a serious competitive threat. The AEP-100 just flew 36 kilometers on water vapor. If this broke it down the way the aviation press wouldn't, hit like, subscribe. We track exactly this. Real specs, real flights, real firsts, called straight every single week, while everyone else is still covering yesterday's concept render. AEP-100 megawatt-class, world's first, already flown, aviation clean future just got a country of origin. And it isn't France, and it isn't America. I'll see you in the next one.